Hi, my dear students. I welcome you once again to another important aspect of our lessons. Today we have data organization, analysis, and presentation. Let me not waste my time. Let me introduce myself once again. My name is Evans. I'm your mathematics facilitator. This channel is Mazwis TV. Don't forget to subscribe, like, and share. As I said, we are going to look at what we have, that is data organization, analysis, and presentation. Today we are looking at a very important aspect of this concept, okay, and that is measures of central tendency. So for the introduction, I know we've already gone through the introductions, how to draw a frequency distribution table and all that. Okay, we've gone through all those aspects. So today we are going to look at this very important concept, that is the mean, the mode, and the median. Okay, yes, that is what we are looking at the moment. All right, so as I said, we'll not waste my time. Let's quickly go to what we mean by measures of central tendencies. So we are saying that a measure of central tendency is a summary of statistics representing the center point or typical value of a data set. We can also see that it is a single value that attempts to describe a set of data by identifying the central position within that set of data. So all that we are seeing is when you take a data set, okay, you want to find the central position, the middlemost position, what value is there. That is what we are talking about. Okay, as I said, we have there are three basic concept under this. But we are also saying that the single value represent what the middle or center of its distribution. Okay, as I said. So we have three main what measures of central tendencies, and I know you know them already. So we are going to go through how to find the mean, the median, the mode when you are given raw data, and also to find the mean. These three measures of central tendencies when you are given what frequency distribution table. All right. So we shall take them one after the other. Okay. So as we said, we have the mean, which is the same as the average. Okay. In some way, or in some books, you may see the mean as what average. So if you see average, know that we are talking about. But in all these three concepts that we are talking about, they are all averages. Okay, but most of the time, we normally use what average for mean. So take note. Then we also have the mode and the median as well. Okay, let's look at where we talk of what the mean. What is the mean? So we are saying that the mean, also known as what arithmetic average, is a measure of central tendency calculated by what summing all numerical values in a data point and dividing by the number of data points. It is always denoted by what x bar. So if you take the mean average or the average, all that we are saying is if you get a data set, just what add all of them together and divide by the number of what values you have, and whatever you get becomes your average or the mean. Okay, for instance, maybe you may be given the ages of particular people and you'll be asked to find the average age. So you just have to add all their ages and then divide by the number of people given, and that is give you what the average or the mean. All right. So if you are given the following raw data as x1, x2 up to x6 to find the average, know that the mean or the average is given by what sigma x divided by what n, sigma x divided by n. So know this formula. All right, great. As I said, as it is given, sigma x divided by what n. So when we talk of the sigma x, what do we mean by, we are saying that is the sum. So in mathematics, when you see that symbol, it means what, sum, sigma. Okay, sum, you are adding all of them. So it's sum of all data points, where n is also what, the number of data points. Okay, so it's very, very easy when you have raw data like this. All that you do is, I know we've done this before, but we still have to go through, because we know that some people still have a lot of challenges. All right, yeah. So if that's the case, then we can add them as it is, and you know that the number of the raw data given is what, 6. That is the n. Then you are good to go. If that's the case, then let's take this example. So let's say you have this raw data. Okay, how do you find the mean? So as I said, it's just a matter of what, summing them, and we know that these are what, 6 numbers. That is the n. So all that you do is just sum all of them. So the mean represented by what, x bar, is given as the sum of these numbers divided by 6, and we get our 30 divided by 6, which gives what, 5. So very, very easy. Some of these things you don't have to waste time on that. Okay, yeah. So if that's the case, then let's look at the mode. Okay, so when we talk of the mode, what is the meaning of the mode? So we are saying that the mode is the value that appears most frequently in the data set. It is a measure of central tendency used to identify the most common value or category in a group. Yeah, so if you take a data set, all that you are saying is those values that appear most or that show up more than the others, they are the mode. Okay, yes. So whatever value you find in the data set, if you see that it appears more than any other value, then that becomes what, a mode. So this one, for getting the mode is very, very easy. When you are given raw data, you just have to go through this. So if that's the case, then we are saying that in a data set, we can have what we call what, unimodal. Okay, yes, so it is a type of mode. And what does it mean? We are saying that for a data set to be unimodal, it means that that data set what, contains what, a single most frequently what, value. That is when you realize that it is only one particular number in the data set that appears more than any other value in the data set. That is what we call, so when situations like that happens, then we are saying that it is called unimodal. Unimodal, that means we have only one mode, okay, in a data set. Then let's take this example. So if you look at this example, you realize that we have 3, and then we, yes, so you can see that 3 appears twice. Then we also have what, a 4, which also appears what, 3 times. Okay, so comparing the two, which appears most, you realize that it is 4. 4 appears more than any of these numbers. For that matter, our mode is giving us what, 4. So mode is very, very easy because it is only one single number that appears more. That's why we call it what, unimodal. Okay, now let's look at this one as well. We can also have what, bimodal. So when we say bimodal, it means that we have a data set that contains what, two um, modes. Okay, when you realize that there are two different numbers which appears the same number of times in the data set, these two numbers are what we call what, bimodal. That means we have only two numbers that appears the same number of times in a data set. Okay, so if that's the case, let's take this example. So you realize that we have 4, which appears what, twice, and we can also have for 7, which also appears what, twice or 2 times. So since we have these two numbers appearing the same number of times, then we see that our mode is what, 4 and 7. Okay, that is why we see that they are also what, bimodal. Okay, so know that we can also have what we call what, multimodal. Okay, that is multimodal. And what does that also say? So when you realize that you have more than 2 values appearing more, that is what we call what, multimodal. All right, that is the multimodal. So for instance, let's take this example. So you realize that we have 4, which appears what, 2 times, and then we also have 7, which also appears what, 2 times. Then we have 2, which also appears what, um, 2 times. So you realize that we have 3 different numbers that also what, occur the same number of times, and that becomes what, multimodal. So when you realize that you have more than 2, okay, values occurring, having the same highest frequency, then we say it is multimodal. We can also have a situation where we don't have any mode. In that matter, we say no mode. Okay, yes, that is when you realize that all the values appears the same number of times. All the values, there is no particular, or there's no single value that occurs more than any other um, value in the data set. Okay, yes, that is when we see that then we don't have any mode. So when situations like that happens and question is being asked to find the mode, the answer you write is that no mode. That is the only answer you write. For instance, if you take this example, you realize that all of them occurs once. You don't have any number repeating itself or occurring more than any other number. So you see the answer is what, no mode. You can also have a situation whereby you have numbers repeating, but you realize that all the numbers are repeating the same number of times. So if you look at 4, you see that it appears what, twice. If you look at 10, you can also see that it also appears what, 2 times. You can also get 6, which also appears for 2 times. The same way you can get 5, which appears the same. You can also get 2, which also appears the same. All right, and then 3 also appears. They are all appearing 2 times. So since they all what occur the same number of times, then this one too, we can also conclude that there is no what, mode. All right, so very, very simple. All right, great. If that's the case, then let's move on to um, another concept, that is what, the median. Okay, the median. So all these that we are looking at only when you are asked to find these measures of central density when you are giving raw data. We haven't gotten to grouped frequency distribution and ungrouped. We haven't gotten there yet. So these ones are basic ones. Okay, so when we talk of the median, we are saying that when you have a data set, okay, the middlemost what, value that becomes what, median. Okay, the middle, that's only when you arrange the numbers according to what, or you arrange them in order of magnitude. Okay, you arrange them either in ascending order or descending order. That is how to find the median. Okay, so for ascending order, that means you are ranging from lowest to highest, and also descending order from what, highest to lowest. Once you are done arranging, you can go ahead and find what, your median. So the middle value becomes what, your median. But let's take note of this. When you get a question, you don't just find the middle number. So there are conditions. Okay, so the first condition is if you realize that there is odd number of value, that is when the number of that is the n, the number of for the data points. Okay, you realize that it is odd. It is odd. So if you count them and you see that these numbers, you've got an odd number, then how do we find the median? It is just the middle number. Once you realize that it is an odd number, then the middle number um, for both the left and the right side, the one in the middle becomes our answer. Okay, so if that is the case, then we say that the median is a middle value. That is what you find what, have n plus 1 position. Okay, you can also find the position. Okay, that is what we are talking about. So we look at all these. Okay, if that's the case, let's take this example, all right, and see how we can find the median. Okay, so first of all, you need to arrange them in ascending order. Okay, as I said, either ascending order or descending order. So in this case, we have arranged ours in ascending order. That's from smallest to what, biggest. All right. Yeah, so let's identify the number of data point. So you realize that we have what the n, we have what 11 numbers. Okay, so once you have 11 numbers, then we have odd. So if we have odd, what does that condition say? The condition says if it is odd, then we find the middle value, okay, among these numbers, or we find the half n plus 1 position. Okay, yeah, so if that's the case, then let's identify the two and the numbers. So we start identifying them from both left and right, the two extreme what ends. Okay, then we identify 10 and then we move like that until we get the middle number. Okay, still we move again. Okay, and then you realize that we have moved each and every number has gotten what counterpart. It's only 4 that doesn't have. So in that case, it means that 4 is the middle number. So um our 4 then becomes what? Our median. That is very simple. So let's use the nth position also to see if we get the same form. So for the nth position, we know that our n is 11. So we just going to what? Substitute the 11, okay, and then add it to 1, making what? 12. Then we multiply by half, or we find, we divide by 2, and then we get what? 6, okay. So it means that we have, for this one, we have what? The sixth position. Now, when you get the 6, it doesn't mean the 6 is our answer. The 6 is not the median. The 6 is only telling you the position of that particular number we are looking for. So you go through the numbers. That is, you can also do that only when you have arranged them. So take note, when it gets to the median, you first have to arrange them in either ascending order or descending order before you even look for the position or you find the middle number. Okay, if you don't arrange them and they are mixed up, you will get your answer wrongly. Okay, so since we've already arranged, let's find the seed position. Which value is that? Okay, so the first one is the first position. The second is this. So we have second position, third position, fourth position, fifth position, sixth position. So you realize that the sixth position is on 4. So the number that you trace and get at that particular position, that becomes what? Your median. So take note of the positions so that you don't get confused, because most of the time students get confused when they find the position, they use the position as the answer, but that's not the case. All right, great. So if we understand it that way, then let's move on. Okay, so once we have that, then we know that it is R4. Okay, so we move on. Now, another condition, what if the n value, the number of data point is even number? How do we find the median? So we are saying that if it is even, then the median is the mean or the average of two middle values of the data set. So still, when you arrange them in ascending or descending order, if you realize that the numbers or the values given, okay, is what? They are what? Even, then you find two middle numbers, or you find the half n and then half n plus 1 position, you find the median. Okay, so let's take this example. Okay, already it is arranged, so no need to arrange them again. Once it is arranged in the question, then we find n, which n is what? 8, and that is even. So we identify the two middle numbers. You realize that 4, we have 3 numbers at the left side, 3 numbers at the right side, but we don't have 3 numbers, we have only 2 numbers left. So it means that these 2 numbers are the middle numbers. So once you find that you have 2 middle numbers, then you have to find the average of these 2 numbers. And you know how to find average. It's the same as finding the mean. Okay, and you know how to find the mean of raw data. Okay, you just add them and then you are good to go and divide by what the number of what times or the number. So we get what? Our 9 on 2, and that is going to give us 4.5. Great, right? Okay, yeah, so that is it. Now let's consider the positions as well. Let's find the positions. and also see if you get the same thing. So we find this position and we will find the other position. So we know that our n is 8. We just substitute the values and then we find these two, yes, positions. Okay, yes, and we know that we have the fourth and the fifth position. So we are going to identify which number of the data set is the fourth position and which number is the fifth position. So we realize that we are going to get 4 and 5, okay, for the fourth and the fifth position respectively. Okay, once we are able to identify these two numbers for these two positions, then we find the average. Okay, and it's the same thing, it gives you the same. So that is 4.5. Very interesting. Okay, if that's the case, then let me give you one to try. Okay, so if that's the case, then I'm giving you a few minutes. Try this one. Okay, then after that we compare to our answer. I only produce the final answer. So you have to work out to get your answer. And when you finish, you compare to the answer I'll provide. Right, so I'm giving you a few minutes. Go through. All right. All right, so you're welcome. Yes, so let's compare. So let's check our answer. As I said, I'm giving you the final answers. All right, so this is what we have. So compare. If your mean age is 40.9, middle is 13, and median is 15. If you got the same, then bravo, you've done well. That's good. So if that's the case, then let's move on. Now, you see that all these examples, all the workings that we've gone through, all these they were when they are raw data, when you are given raw data to find, it's very, very easy. Okay, let's look at when you are to find these measures of central tendency in an ungrouped frequency distribution table. You know that we have grouped one. When you talk of an ungrouped, okay, that is when these data sets are not put in classes, okay, they are not put in categories, they are not put in what classes, yes, in their respective groups. Then we say it is ungrouped data. All right, but when you put them in their classes, maybe in a certain range, for instance, maybe you can say you are putting them according to ranges or classes, for instance, maybe 5 to 10, um, 10, 11 to 15, 16 to 20. Yes, those categories or classes, that's what we see what we have grouped frequency distribution table. But if they are not put in those classes, then we say they are what? Ungrouped frequency distribution. Okay, so first of all, what is a frequency distribution table? So we are saying that it's a table that lists distinct values, categories, or numerical ranges, that is classes alongside their corresponding what frequencies in a data set. Very interesting. All right, so let's take our table. So this is what a frequency distribution table. Now the range, we are talking about the classes, okay, the groups, okay, what particular data set, how you are going to put the data set, you are going to arrange the data set, or you are going to summarize the data set. That is where we put them. Then for the tally talks about the number of times these data set they appear. Okay, the number of times each of the values appear. Okay, then the frequency also talks about the number of times, but we use the tally. Okay, depending on the tally, okay, that gives what the number of times that they also appear each of the data set. Then for fx, that is when you are finding out the product of the range and the frequency. Okay, that is it. If that is the case, what we are going to do is that we are going to take one particular example, then we use it, we generate our table, then we use the table to find the mean, the mode, and the median as well. All right. So let's say we have this as our example. So the marks obtained by these groups of students. Okay, let's see how we can do that. Great. Yes, so if we have this example, then let's draw our table. So we have this as our frequency distribution table. So we are going to arrange all this. Now, you see that when you arrange them in the marks, that is the range. Okay, because so the range, whatever is given in the question, that is what you write at the range or column. Because at the range column, okay, in the question we're giving marks. That's why we are using what marks. If we are giving ages, you use ages. If you are giving um, um height and scores, put whatever is given in the question there. That is for the marks column. All right, great. So you start writing the numbers from smallest to highest. So you look through and realize that we have 12, which is the smallest, and 26 is the biggest. Okay, so write them based on that. Okay, so we have 12, 14, 15, 16, 19, and 26. Yes, that is the number. So that is how we write them because I said it's ungrouped. Okay, then we are going to use the tally. As I said, we are going to use strokes. I know you've remembered this, you know this already. Okay, yes. So we start with the 26, we mark it, we record it as a stroke under the tally column, move to 12, we record it to it corresponding, move to 14, we record it, we move to 15, we record as well. So that is what we are doing. Anytime you record to their in their respective what column, that is what we are doing. So we are doing all this once, okay? We are recording all of them. Very interesting, okay? So it is not anything difficult. It is all that we did in GHS. That's why we are throwing more light on that, okay? So my dear student, these ones are very basic, okay? So when you meet some of these things, you don't have to waste time on that because we've done this in GHS. Okay, so it's the same thing. It's just that here we throw more light, okay, and we add more. That is it. So now remember, you see that I've crossed the black one, the black line crossing the red. So it means that when you record with the strokes and you realize that you have gotten 4, then the fifth one you use it to cross it. That's why you see that it is crossed. So we see that every after every 4 strokes, there will be one black dot crossing. That is the meaning. So it means that the fifth we use to cross it. Yes, I know we did all these in teachers and we are doing the same. So once we are done, then it means that we are going to what? Record what? The frequency. Okay? Yes. So for the frequency, we record it based on the strokes we have under the tally what? Column. So you look at the number of strokes in each tally, then you record under the frequency column. Okay, so for 12, we have the first one, we have how many strokes? We have 4. So we record 4. It means that the number of students that scored 12 marks, they were how many? 4. So the frequency gives the number of what students. Okay, then we go to 14, also 6. It means 6 students got what 14 marks, 7 students got 15 marks, 2 students got 16 marks, 5 students got 19 marks, and then 6 students got what 26 marks. Then finding the sigma f and finding the fx, that is just the product. So we multiply 12 by 4 gives us 48, 14 by 16 gives us 84, then we have 15 times 7 gives us what 105, we have 16 times 2 gives us what 32, and 19 times 5 gives us 95, 26 times 6 gives us what 156. Once we are done, then we are going to find the totals. Okay, so we find the total of the frequency, and that is what the sum. So we use the symbol sigma f. So if you add all of them, you get 30. It means that the total number of students that took the test were they were was 30 students. That is it. Then we find sigma fx. That is when we sum f of x fx. That is it. Great. So now that we have calculated all these totals, then let's quickly find these 3 measures of central tendencies. So let's find our mean, okay, in an ungrouped frequency distribution. Okay, yes. So for the mean in an ungroup, it's just what divide, and it's the same as when we're doing the raw data. You sum all the data points and divide by the number of data points. So here, the number of data points in a raw data, the sigma f represent the n, okay, and the sigma fx represent what the sum of all data set. But in a frequency table like this, that is how we do it. So you see that in a frequency table for ungrouped data, that is what sigma fx divided by sigma f. By then, you have calculated for your all these ones. So you just do substitution and you are good to go. And then you are going to get what 70.3333. So the 3 is repeated, so it's approximated. Okay, and that becomes our mean. Very, very easy. So this one we don't have to waste my time on that. Now let's quickly move on to how to find the mode. Okay, yes. So for the frequency distribution table, we are saying that the mode is the range with the highest frequency. So we know that the range is the max. Okay, so that the mark, we are talking about the mark with the highest frequency. So you go through the frequency, the one that you think is the highest, it corresponding value in the marks, that becomes our mode. Okay, so it's very, very interesting. So if you go through the frequency, you realize that we have the 7, that is the highest frequency among all these frequency. That means the number of people that, or the particular group of people who are more than the rest, and what a particular what marks. Okay, that's what we are talking about. So 7 people, they are more than them. So you trace it corresponding mark, then that becomes your mode. It means that our mode is what 15, because it is the 15 with the highest frequency, the mark with the highest frequency. So please take note, most of the time students make mistakes here. When you ask them to find we tell them the mode is the mark or the range with the highest frequency, because they realize that the 7 is higher, then they will choose the 7 as the answer. Please, you are not choosing from the frequency. The frequency is only helping us to know the right answer. Okay, yes, so our answer is gotten from the marks, not the frequency. So take note of that. All right, that is great. If that is the case, then let's find our median. Okay, so the median from a frequency table, we have conditions as well. So to find the median, first you need to find the total frequency, that is the sigma f. Then after that, if the sigma f that you have gotten is an odd number, so this one is also same as when we're doing the raw data. So we are saying that if it is an odd number, then you find the half of sigma f plus 1 position. Okay, and after finding that position, then you start adding the frequencies. You go to the frequency, okay, the numbers in the frequency column, you start adding from top. Okay, you add until you get a number, okay, where that the half of f, the half of what the sigma f plus 1 position, where you find that number within, and you trace and find it corresponding what a mark, that becomes your median. Okay, so that is what we are talking about. Then what if it is uneven? So if it is uneven, then that one do the same thing. You are finding what half of sigma f position, and then half of a sigma f plus what 1 position. Then you trace that one to, you trace their corresponding what marks. Definitely you are going to get 2 numbers. Then when you get 2 numbers, you just what find the average, and you know how to find the average. So this one is the same as what we're doing now, just that this one it is done in a table. Okay, so let's get back to our table. Now we know that our sigma f is 30. So 30 suggests that it is what even, it is not odd. Then if it is even, use its condition. So if it is even, then it means that we need to find these positions. Okay, so we know that sigma f is 30. We just substitute the values. Okay, yes, then we find these positions. Once we are able to find the positions, then we find their corresponding what entities from the marks. Okay, so we know that we have the 5th position and we have the 16th position. So what you do is you go to the frequency column, you start adding. So we are finding the 15 first. After that, we find the 16. Okay. So for 15, we start adding from 4 to 6 gives us what 10. 10 is still less than 15. Then we add the next value, which is 7. Okay, we add that value as well, and that will make us 17. So now that we have gotten 17, we have gotten a number that is greater than we can find the 15 within. So you realize that the 15 is within what? 17. So perfect. Then you ask yourself, which number did you add to get a number that the 15 is within? You realize that we reached was 7 in the frequency. Then if it is 7, then you trace it corresponding with value in the max. Okay, yes, great. So on the 15th, on the 15th position, the value of we are getting in the max column is 15. Okay. Yeah, so it means that once we have gotten the 15, okay, so that means for the 15th position, we are still getting 15. Please note that that 15 we are getting, it is not because we have the 15 with the TH. That's not our answer. The 15 with the TH is only helping us to know the position. So take note of that. It's just position. Then we find the value at that position. So the value at that position is what? 15. So it's coincident that the fifth it is 50th position and we are still getting a value which is 15, the same values, but that doesn't mean that because it is 15, we are using the 15 for the TH. No. Okay, so once we know that, then we can say that the 15th position, our value is what? 15. Then we do the same to the 16th position. So that one to the same thing, you start adding from the top of the frequency until you get a value within which we find the 16. Okay, so if you add 4 to 6, you get 10. You add 7 to 8, you get what? 70. So you realize that even the 17 that we got for the 15, still the 16 is less than the 17. So we can still find the 16th position within the 17. Okay, so in that case, and it was also on the 7th of the frequency, okay, that we got that position. So it means that our 16 is also going to be the same as 15. Okay, for that matter, we can see that the 60th position is also 15 what value. So we have a value at the 16th position, which is 15, the same as 15. So both 15th and 16th position, we still have the same 15 at those two positions. So once you know that, then after finding these two numbers, you find the average, the mean of these two numbers. And finding the average is very, very easy. We've done that already because they are two. So we can say that our median is 15 plus 15 divided by what? 2, and that gives us 30 divided by 2. And for that matter, we have what? 15. Very easy. So I said, I'm repeating again. Okay, I'm still repeating. I'm saying that this 15 we are getting as our median is not the 15th position. Okay, and it is not also because we trace and we got 15, that's why you are getting 15. No, there are times that depending on the question, there are times that you may even get decimals. Okay, you may get decimals. When you get decimals, doesn't mean because when we found the corresponding, we got 15. So the answer should also be 15. No, okay. We are finding the average, and because of the numbers given in the question, that's why after finding the median, we are still getting what? The same 15. So take note of that. When you are finding, to get the right answer, when you are finding the median from ungrouped frequency distribution table like this is how we do. We go through these procedures. Okay, you are going to get the right answer. So if that's the case, then let's end here and continue next time. Okay, yeah, so my name is Evans. I'm still your mathematics facilitator. Here is Mazris TV. Don't forget to subscribe to my YouTube channel and also follow me on TikTok and Facebook. But please don't forget to share, like. All right, so if that's the case, then let's end here. But in our next video, we are going to look at how to find these three measures of central tendencies in a group frequency distribution table. This one we have done what on group and we have done raw data. So we are going to look at a group one. Okay, and we also find some application questions for these three concepts. All right, if that's the case, then see you next time. Bye bye.